This will begin our Section 2.2 lectures on operations with fractions. Our objectives this time around are meanings of fractions, division by zero, multiplying and dividing by a number by one, which we'll cover at the end of this section, dividing a number by itself, prime factorization of number, and simplifying fractions. Now I'm going to probably be throwing quite a bit in here, so I expect this set of lectures to be 5, 6, maybe even 7 lectures long, because there's a lot to cover. As I've told you in class, as I've mentioned before, that fractions are really, really important because we need those basic concepts for other things later on. First of all, let's review or learn some vocabulary for fractions. First of all, we have this number up here. We call that the numerator. So the top of a fraction is the numerator of the fraction. The bottom number is called the denominator. And this line down the middle, that's called a fraction bar. Fraction bars do mean division. Fraction can also represent division. So we have, what is the numerator of 5/8? So over here, and we have the 5/8, our numerator is this number up here. It's the 5. So 5 is the numerator of our fraction. Our second fraction here, what's the denominator of 19/97? 19/97, the denominator is the bottom number, it's 97. So 97 is the denominator of our fraction 19/97. Now what we want to talk about is what a fraction really means. What does it represent? So you see a couple of pictures drawn over here that we're going to use to figure out what the representation is in a fraction. So first of all, what we need to know is a fraction represents parts of something. The numerator represents how many pieces we're discussing, and the denominator tells us how many pieces a whole has been broken into. Now if we talk about a proper fraction means that we have one whole item being broken into pieces, and we're discussing less than one whole item. If we're talking about an improper fraction, we're talking about a whole or more than a whole. If we're talking about two or more wholes, each of the whole things are going to be broken into the same number of pieces. That's very important. So here you'll see these two whole things broken into the same number of pieces. So let's discuss this first one up here. We're going to represent the shaded portion as a fraction. So the first thing we need is the denominator. The denominator tells me how many pieces this whole has been broken into. It's broken into 1, 2, 3, 4 pieces. So the denominator is a 4. And the numerator tells me how many are shaded. So 1, 2, 3 are shaded. So the representation of this shaded figure is 3/4, or 3/4 is another way of writing that. Now we're going to go down and look at an improper fraction. So each of these whole pieces has been broken into fourths. So just like the fraction above, the denominator is going to be a 4. You don't want to use all 8 of them. You say 4. Each whole has been broken into 4 pieces. Now we'll count the total number that are being shaded. So there's 1, 2, 3, 4, 5 that are being shaded. This is an improper fraction, 5/4. Now we're also going to learn that improper fractions can be written as mixed numbers too, and that means that we have one whole figure and one of 4 being discussed as well. So another way of representing this, and I'm just going to circle this because this isn't our answer. This is our answer, 5/4. But another way of representing this would be one whole and 1/4. And notice that use of and. We'll talk about that a little bit later. Now, one of the next things that we want to do is we want to learn how to put a fraction into lowest terms. Lowest terms mean that we have no factors in common. Factors, remember, are pieces of a multiplication problem. And so we're going to have to learn different ways that we can find the factors of the numerator and denominator so that we can take all of those out. There are 2 different ways of doing that. One is using the greatest common factor, and the other uses prime factorization. Now both have their places, and we will use aspects of both of them. So I want to teach them to you, and both of them to you. But I want to make sure that we really understand how to do prime factorization, especially because we will use that at the end of the semester as we do our rational